Download this code from codegive.com, link in the description below. Async compute on PC, a comprehensive tutorial. Asynchronous compute is a powerful feature in modern graphics APIs that allows developers to issue compute workloads alongside graphics workloads, leading to better utilization of GPU resources and improved performance in graphics-intensive applications, like games. This tutorial will cover the basics of asynchronous compute, its benefits, and provide a code example using Vulkan, which is a low-level graphics API that supports async compute. What is async compute? In traditional graphics rendering, the GPU is often underutilized because it waits for the completion of one task before starting another. Asynchronous compute allows you to run compute tasks, like image processing or physics calculations, concurrently with graphics rendering. This can lead to better performance, especially on GPUs that support this feature. Benefits of async compute. 1. Better GPU utilization. More tasks can be run simultaneously without waiting for the completion of previous tasks. 2. Reduced latency. Tasks that can be computed asynchronously can reduce the overall time taken for frame rendering. 3. Improved performance. In scenarios where compute shaders can be used to offload work from the CPU and benefit from parallel execution on the GPU. Prerequisites. To follow this tutorial, you need 1. Basic understanding of C++, familiarity with C++ programming language. 2. Vulkan SDK, installed on your PC. You can download it from the LunarG website, https://vulkan.lunarg.com. 3. A Vulkan-capable GPU, ensure your GPU supports Vulkan and async compute. Setting up your project. 1. Create a new C++ project and link it against the Vulkan SDK. 2. Include necessary header files for Vulkan. Sample code. Here's a simplified example of how to set up async compute in Vulkan. Explanation of the code. 1. Creating a compute pipeline. The create compute pipeline function initializes the compute pipeline by creating a shader stage and pipeline layout. 2. Executing async compute. The execute async compute function records commands for both compute and graphics command buffers. 3. Submitting command buffers. First, the compute command buffer is submitted, followed by the graphics command buffer. This allows the compute shader to run asynchronously while the graphics pipeline is rendering. 4. Synchronization. The queues are waited on to ensure that the commands have completed before cleaning up resources. Conclusion. Async compute is an advanced topic that can significantly improve the performance of applications that can leverage it. This tutorial provides a basic framework for implementing async compute using Vulkan, which can be extended and modified for more complex scenarios. For a deeper understanding of Vulkan and async compute, consider exploring the Vulkan API documentation and additional resources on shader programming.